So number 23, we are going to condense using what property? The product, quotient, or power? What do you think? Product, right? So you're going to take both log base 10s and make them one single log base 10. By the way, you don't even need to write the base 10 because it's a common log, but we're doing it anyway. And the product property says that when you have plus signs with the two exact logarithms, you could write them as one logarithm as long as you multiply this guy with this guy. So let me write them both together. You could write it as 4 times w, or just jump to the answer, which is 4w. So you have log base 10 of 4w equals 2. So now that you have common log of this whole side, you could actually raise both sides of the equation to become powers of the base of your choice, in this case base 10. That'll cancel it out, so you have a new simple equation, 4w equals 10 squared, which is 100. 4w equals 100, which means that when you divide by 4, w will equal 25. What you want to do is just have one single log base 7 and one single log base 7, but right here on the left side alone you have 3 log base 7s. So to get rid of a log, you want to have one single log on both sides. That way you could raise both sides to be powers of base 7. Then you could get rid of it. Right now you have 1, 2, 3 logs on one side. That doesn't work. So we need to definitely condense. So which one are we going to do first, product or quotient? Let's go with left to right. So let's go with product. So let's, and not only that, we can't even condense with that yet because there's a 2 out in front, right? So let's first get rid of that 2 by using the power property and moving it up here and making it an x squared. Are you with me? So actually the first property that we're applying is the power property. Makes sense to do exponents before multiplication or division. So we're doing the power property. Now let's do the product property. That says that if you have common log, or not common log, log base 7 and log base 7, you could write them together as one single log base 7. But of course, you have to multiply the x and the x squared. So you're going to put times, or x times x squared right here as the log base 7 of that. Of course, this is showing my work. X times x squared is x to the third, so we really have log base 7 of x to the third. And of course, we're going to bring down the rest of this left side of the equation, which is minus log base 7 of 3. Right? So both of these became this. We still have the minus log base 7 of 3. Let me bring it down. And now we're going to apply the quotient property because there's a minus sign between them. When we apply the quotient property right there, again, you're going to take the log base 7 that you have here, log base 7 that you have here, and write them as one single log base 7. And the quotient property says that you take this one and divide it by this one. So it's going to be x to the third over 3. And there you have it. We have condensed the entire left side. That huge, long, disgusting thing up here becomes log base 7 of x to the third over 3. Now we still have the equal sign that comes down, and we still have the right side to deal with. On the right side, we have log base 7 of 72, and that's good enough for me. Let's just bring it down here. Log base 7 of 72. Okay, so at this point, we have this equation in red, and we could actually get rid of the log base 7s by raising both sides to be the power of base 7. Like I said, this work is kind of pointless to show. You're just going to scratch out log base 7s. You have a new equation that reads x to the third divided by 3 equals 72. And from there, of course, we're going to get rid of the divided by 3 by multiplying by 3, multiplying by 3. So we end up with x cubed equals 216. And now we're going to get rid of the cube by doing the cube root. So we're going to do the cube root here and the cube root over here. We will get x equals 6. Because 6 times 6 times 6 is 216. There's your final answer. The only other thing you need to do is make sure that when you plug it back in, you don't end up with negative values inside your logarithms. So if you go back to your original, The 6, it goes in here, there's no negative value in there. The 6 in here, no negative value. The 6, there's nowhere else to plug it in. So we're good. That's the answer, x equals 6. So what happens if you do plug it in? Like let's pretend that this equation had plus log base 7 of let's say x minus 8. Yeah, let's pretend that was part of the equation. It's not, but let's pretend. So let's say you got the answer 6, and when you plug it back in, 6 take away 8 is what? Negative 2. So that would mess it up. That would cause this to be an extraneous solution. So, I mean, in this case, since there's only one answer, and that answer wouldn't work on all of them because it ends up with a negative, then you would say no solution. You would say that this is an extraneous solution, so there is no solution. But of course, this wasn't part of the original equation. It actually didn't produce any negative numbers in there. So 6 does work. 6 is the answer.